asking.
Okay, please
So,
start.
Pawan, uh,
Yes, yes.
uh, please describe the basic principle used in electrical method.
Yes, sir. Sir, a basic principle we use in electric method is Ohm's law, and that is that voltage is proportional to the current, and by Ohm's law we obtain the resistance and resistivity of the materials.
Okay, what are different methods we use in electrical method?
Yes, sir. In electrical method we use cell potential, and IP method also used in electrical methods.
Okay, another is resistivity method.
Yes.
So, briefly describe the differences among these methods.
Yes, sir. Sir, in resistivity method, this active method, we use a current source which is insert in the earth, and we measure the potential, which is occur due to the current. And by the measuring the potential, we measure obtain resistivity of the subsurface. And sorry, cell potential is a active method. Sorry, sir, passive method. We use the which is a potential generate the natural event, like a electrochemical process and a mechanical process, and we measure the voltmeters. And sir, in the induced polarization, also a active method. We use the we insert the current, and after that switch off the current, and we measure the over voltage, that is delay voltage in the subsurface.
Okay, so let us start with resistivity. What are the basic configurations we use in resistivity method?
Yes, sir. Sir, in resistive methods, we use different configuration. One is the Wiener configuration, another one is Salemberg dipole, pole configuration we use.
And what is this configuration all about?
Yes, sir. Sir, in bigger Wiener configurations, the separation between the successive two electrode are common. We use like a, and sir, in Salemberger, the separation between the voltage electrode are is much smaller compared to the separation between the current electrode. And sir, in dipole, we use two current electrode, and the between the and voltage electrode are much far. And in pole we use one current electrode or one electrode, one voltage electrode, and other current and voltage electrode are very far compared to the one current electrode and voltage electrode.
Okay, uh, now arrange in the order of propagation, penetration depth.
Yes, sir. Sir, very depth of penetration is very large. Pole configurations, and after that dipole pole, and dipole, and Schellenberger and Werner.
Okay, now next, I think for now I am done. Next, somebody can ask question now.
Thank you, Amrit. Agya, would you like to ask?
So Pawan, can you
Yes.
say why the pole method gives greater penetration depth, as you said earlier?
I think, sir, depth of penetration is of electrode. So in a pole method, separation of the current electrode and voltage electrode for is very large compared to the other configurations. That we can say that we can assume that infinity compared to the two current electrode, and compared to the one electrode and current electrode.
Okay. In resistivity method, what are the two profiles, two methods we use in
Uh,
resistivity method?
yes, sir. Sir, in a resistive method, we use two profile. One is the resistive profile. Second is the resistive sounding. Sir, in resistive profile, we use lateral variations of resistivity, and in resistivity sounding, we use horizontal variations like if we like a vertical variation with the depth in resistivity sounding.
Okay. And so in what case we use the vertical sounding, and in what case we use the lateral profiling?
Uh, yes, sir. Sir, in lateral profiles, we when we vertical discontinuity we obtain, then we use lateral profile. If we use horizontal discontinuity, then we use resistivity sounding.
Okay. And what do you mean by apparent resistivity?
Sir, apparent resistivity is that the average resistivity, which is the ore body and its surrounding.
Please, I don't understand. Please say it again.
Yes, sir. So I will say that apparent resistivity is not the true like a ore body. It is depend on the ore body and the surrounding. Maybe apparent resistivity is the true ore body, or maybe its surrounding body.
Okay. Can you say what are the probable cause of the arising of the self potential? Why does it occur?
Yes, sir. Cell potential. We can say that some process like a mechanical process and electrochemical process, and sir, this type of process, then the in subsurface occur cell potential.
Okay, what type of anomaly we can see in self potential over a mineral or ore body?
Sir, in cell potential, we have a two type anomaly. One is the positive, another one is the negative. And sir, for ore, if we ore body is like a sulfide ore body, so we obtain the negative anomaly.
Do we obtain positive anomaly over something?
Sir, for positive anomaly, we use like a quartz and peritite minerals where we obtain the positive anomaly. And sir, if you buy electronic like a electronic process, we obtain the positive anomaly.
Okay, thank you. I am done.
Okay. Vidyut?
Yes, yes, yeah. So, Pawan, what is main concept behind about the induced polarization?
Sir, main concept of the for induced polarization is that we have two main the induced polarization, basically the electrochemical process. We have two grain polarization. Another one is the membrane polarization. So by electrolytic polarization and electrolytic polarization due to the produced induced polarization.
So, what is electrode polarization?
Sir, electrode polarization is that when we it's similar to the cell potential. We can say that a electrode is if we it's contact to the electrolyte like water, say, then due to the oxidations, we obtain the polarization between the electrolyte and minerals. You see the electrolyte polarization.
Okay, so in between these two polarization, membrane and electrode polarization, from which you will get more voltage.
Uh, I'm not sure, but membrane polarization are more voltage.
Why?
No, sir, membrane polarization produced by two process. One is the by construction within a pore channel, and another thing is that if the presence of the clay, then sir, clay have a negative, though then we can say that the induced polarization also much more compared to the electrode polarization.
Acha. Then comment on metal factor.
Sir, metal factor depend on the sir, metal factors depend on the low frequency resistivity and high frequency resistivity. So the ratio of and also depend on the polarization potentials. So we can see the formula of a metal factor is that rho 0 over A1 minus 0 A2 upon 0 A1 0 A2 multiply A. A indicate the integrations and of between the two times in which we obtain the polarization potentials.
Okay. So what is the importance of chargeability in this induced polarization?
Sir, more chargeability indicate that more induced polarization occur, and low chargeability indicate that low induced polarization occur within surface.
Why you say this more chargeability means that more induced polarization?
Sir, charge ability depend on the induced polarization and obtained polarization. So by charge ability, we obtain the induced polarization within the time period. So sir, we cannot measure the we cannot measure the by instrument exact induced polarization, but in charge ability we can measure.
Okay. So what are the main application of induced polarization method?
So application of induced polarization is that mineral explorations and groundwater explorations, environmental and engineering sites also we use, and sir metal explorations also. And sir, induced polarizations are not dominant for massive bodies. It's dominant for small particles of materials.
Okay. So which type of mineral are delineated by SP method?
Sir, SP method we use sulfide ore bodies like pyrite, perovite, calcite, and granite.
Okay, okay. Okay, Asudip, I am done.
Okay, thank you.
Yeah, one thing. So Pawan, you said na that more voltage generated from membrane polarization. I think it generated from the electrode polarization because the electrode polarization uh, happening presence of metal, and due to this metal there will be more voltage generated.
Okay.
Because membrane polarization, what happened? Because in membrane polarization, in the presence of the electrolyte, right? So in the presence of the ion and electrode polarization, there will be presence of metal as well as electrolyte. So because here is the two effect, electrolytic ion plus metallic ion, metallic electron. But in membrane polarization, only the electrolyte, right?
Okay.
You got it?
Okay, I got it.
Yeah, yeah. Otherwise, all the answer are right.
Thank you. Arpita?
Yes, Pawan, can you
Yes.
tell me? Hello, am I audible?
Yes. Yes.
Can you tell me that as we know that electricity is conducted through the appliances like the wires that are made up of copper, or we can say that are made up of conductor. So, but in electrical methods, we are seeing that we are measuring the resistivity and conductivity through the rock, right? So, how electricity is conducted through the rock?
Arpita, can you repeat?
Hello,
Yes, yes. Yeah.
shall I repeat?
Yes. Yes.
I am saying that as we know that electricity is conducted through a conductors only. Like we are seeing that it is passing through the home appliances, through the wires made up of copper, aluminium, or something, some conductors, right? But in
Yes.
electrical methods, we are seeing that we are measuring resistivity or conductivity, right? So how electricity is conducted through rock?
So, which yes, I got it. Yeah. So yeah, when we insert the current in the subsurface, so in
Afika,
subsurface
you
have
can mute yourself.
yeah. So I got it your question. I'm say that if we follow the current in the subsurface, then in subsurface we obtain the some conducting materials. So by influence of the current, in influence of the current, the charge ions also in the subsurface also groundwater also presents. We can say the electrolytic also present in the groundwater in subsurface. So we can say that by through the current, the charge, the interaction between the conductors and the groundwaters, and electrochemical reactions are produced. So due to this process, potential is generated in the subsurface.
Okay, can you define Ohm's law?
Ohm's law indicate that if we apply the voltage in the circuit, then currents also proportional to the voltage.
Okay, and what is the constant after removing the proportionality sign?
The constant is the resistance of the material.
Okay, so can you define resistance?
Resistance indicate that resistance is the property of the materials. It's opposed the flow of the current.
Okay, on what factors does the resistance of a material depend?
Resistance depend on the uh, cross section of the area where we flow the current, and length of the materials, and the resistivity of the materials.
Okay, what is resistivity?
Resistivity is also a physical property of the materials. Oppose the flow of the charge current.
Uh, there are different types of electronic conduction, right?
Yes, yes.
Electrical conduction. Yeah, can you name them?
Yes, we have three type of electrical conduction. Electron conduction. One is the electrical conduction, which is follow the electron. Another one is the insulator conductions. The electrical conductions, which is due to the presence of the electric field on the materials, that is polarization. The third one is the um, electrolytic conduction, which is follow the ions.
Okay, can you tell me what is the dielectric current or displacement current, you can say?
Yes, yes. This displacement current is depend on the change of the electrical field, uh, or I'm not sure. I'm not about the right now about the recording.
Okay, which Maxwell's relation tells about the displacement current?
Uh, with Maxwell equation,
Yeah.
third Maxwell equation tells about the no, sorry, fourth Maxwell equation tells about the displacement current.
Okay, is there any difference between conduction current or displacement current?
Conduction current is full of the electrons, and displacement current. Sorry, I am not know.
Okay, so what is can we say that dielectric or insulators are same?
Insulator materials in which no current flow, and dielectrical materials, if we put the insulator on the actual magnetic field, then it can be flow the currents.
Can you repeat, please?
Insulator materials in which we not flow the currents, but in dielectricals it's flow the current
How the flow of current takes place in dielectric?
by induced polarization.
Fine, okay. And what is the polarization?
Polarization indicate that if we materials which is put in the external electric field, then due to the electrical field, the separation between the positive and negative ions, then we can say that there is a induced dipoles due to some electric field also produced. So we can say that this is charge separations between the
Okay. What is the order of conductivity for insulators?
for nuclear.
For insulators, yes.
Sorry.
Okay. Can you differentiate between conductor, insulators, and semiconductors?
Yes. Conductor have a we can say that a conductor have a more conductivity, and insulator have a low conductivity, and semiconductor have a conductivity between the which is larger than the insulator and lower than the conductor.
On the basis of band theory, can you differentiate them?
Yes, yes. Sir, in a conductor have a free electrons. So if we some energy, then flow the current. So we can say that the free electrons and semiconductors, the uh, band energy of the semiconductor are lower compared to the insulator. So we can say that in a conductor balance, we can say that conduction. Sorry, I am not recalling right now.
Okay, it's okay. Thank you, Pawan. It was good.
Thank you, Arpita. Sanu?
Hello?
Yes, Anuj. Yes.
Okay. Okay. Can you tell me the application of the resistivity survey?
For resistivity survey, we use mineral explorations, groundwater explorations, bedrock depth we use, and cavity. We obtain some cavities in groundwater by resistivity method.
Okay. And what are the limitations of the resistivity survey?
Yes, yes. Resistivity survey, depth of penetration are smaller compared to the bell logging and seismic method. And second is that investigation ambiguity is also present in resistivity method. And third one is that by topography and near surface density variations, which influence of the readings we will measure in the resistivity survey.
Okay. Okay, you earlier mentioned that the three type of the conduction, electrical conduction. So which one is dominant?
Electrolytic conduction is very dominant.
In all case?
And in all case, I think I'm not sure, but in cell potential we use, then this type of case, electrolytic conduction are very dominant.
Okay, means cell potential electrolytic. Okay. In IP method, which one is dominant?
In IP methods, also electrolytic conductions are dominant.
Hello?
Yes, yes.
Okay, 1 minute. My net connection is not. Hello?
Yes, Anu. Yes.
Okay. So in IP method also electronic means electrode polarization is dominant.
Yes.
अच्छा, can you briefly
Voice
tell?
clear नहीं आ रही है.
मेरा वॉइस क्लियर नहीं आ रही है.
हाँ, अब ठीक है.
Okay, I have a little bit internet issue here today. Okay, next question is, can you briefly explain the IP method?
Sir, IP method have produced two polarization. One is the electrolyte polarization. Second is the membrane, yeah, electrolytic polarization. So if we
No, no,
discuss
actually,
the
no. I'm asking that what is IP method? Means what we are actually measuring. Means what is the
yes,
process?
okay. Sir, in IP method, if we first we insert the current, and after that we measure the, after that we after sometimes we of the current. So we measure the how potential delay with the times. That is the induced polarization we measure in the IP method.
Okay, okay. And means IP method is also work like a battery, na?
Yes, yes, yes.
Okay. And what is the chargeability?
Sir, chargeability indicate that if we materials have its more chargeability, so we can say that the induced polarization is more in the subsurface, and sir, chargeability by chargeability we obtain the induced polarizations.
Okay. Okay. In means in a when we are doing the resistivity survey, so we are using the ONR Stromberg. On what basis? Means when we are using the ONR and when we are using the Stromberg or dipole pole.
Yes, sir, and we use different configuration depend on the situations. Like if we use in a IP method, we use dipole configurations, and if we use if we measure verticals, if we measure vertical sounding, then we use Vega configurations. Oh, sorry, sir, Schlumberger configuration.
Okay. And the vertical sounding means vertical sounding depend on which factor?
So vertical sounding depend on the horizontal discontinuity in the subsurface.
Horizontal discontinuity.
Yes, I'm sir, not sure, but if the we obtain the horizontal discontinuity,
Horizontal or vertical?
yes, sir, horizontal discontinuity.
Okay. And the in vertical electron sounding means when three layer case.
Yes,
So how many means type of configuration we get in three layer case?
yes, sir. If we
Means
three layer case, yes, so we have theoretically four configurations. One is the type A, type Q, type R, type K, type A, type Q, or type R.
type R.
Type H, sorry, type H.
Okay, okay, okay. So can you explain a little bit what this types?
Yes, sir.
If
Yes, sir.
you
Yes, sir. In type A, resistivity is increased with the depth, and in type Q, resistivity decrease with the depth, and in type K, rho 1 is less than rho 2 and greater than rho 3, and type H, rho 1 is greater than rho 2 and less than rho 3. And so rho 1, rho 2, rho 3 is the layer 1, layer 2, layer 3.
okay. Next. Okay, I'm done. Anyone can ask.
Thank you, Shanam. Gauri?
Yes,
Yes,
yes, Pawan, can you give any applications of SP methods?
Yes, ma'am. The application of SP method, we use metal explorations, and another thing is that massive ore bodies, we obtain the cell potentials, and sir, and ma'am, we use environmental and geological sites also. We use helping cell potential like geological mappings and groundwater explorations also.
Okay. What are the causes of this SP method, SP potential, self potential? Origin of SP potential, reasons for the origin of SP.
Yes, ma'am. The reason of the origin of self potential is one is the mechanical, and another is the electrochemical.
Okay, which one is dominant in this?
Ma'am, electrochemical potential is much dominant compared to the mechanical.
Okay, then what are the field techniques we are using to measure this SP?
Yes, ma'am. We use two method. One is the total field method, and another is the gradient method to measuring the cell potential.
Can you describe that? Two
Yes,
methods?
ma'am. Yes, ma'am. Ma'am, in total field method, another name is that fixed basis station. In total field method, we have a reference station, like we obtain one electrode is fixed on this place, and another electrode we move to the service site. So in this process, we obtain the cell potential by voltmeter. Voltmeter have a more sensitive, cell potential have a very small in the millivolt. And second thing is that gradient in gradient method, another name is that the separation between the electrode are fixed. So so we can measure the two electrode, which is separation between the two electrodes. Electrode is fixed by we measure on the survey field.
Which one is prone to more error? Which method?
Yes, maybe in gradient method we obtain the more error compared to the fixed total field method.
What is the remedy method we use to reduce this error?
Ma'am, can you repeat?
In this gradient method, since there is a more chance of occurring error, we use a technique to reduce this error.
Sorry, ma'am.
Okay. Then what are the okay? What is the nature of the input we are applying in IP method?
Ma'am, in IP method we use current flow in the current in the ground in the subsurface.
What is the nature of it?
Ma'am, I think I'm not sure, but DC and also low frequency AC current we use.
Okay. How is this different from the current we are using in electromagnetic methods?
Ma'am, can you repeat?
How is this different from the current we are using in electromagnetic method?
Sorry, ma'am.
Okay. That's all from me. What's the range of the potential we measure in SP method? Range of
Ma'am,
the value
yes,
potential.
yes,
Yeah.
ma'am. Millivolt.
Okay. Okay. That's all.
Hello, Pawan.
Yes.
So what do you understand by geophysical methods?
Sir, in geophysical method, we obtain the different physical property of the Earth by using the different methods. If we use gravity method, so when we measure the resistivity, sorry, density of the materials, and we use the electrical method, then we use resistivity and conductivity of the materials.
Okay. So how many type of electric method do you know?
Sir, electrical method we use a cell potential method, induced polarization method, and resistivity method.
What is the basic principle here?
Uh, Sir, a basic principle of resistivity method is that Ohm's law. That we can say that if we apply voltage on the conductor, then it follows current, and the value of the current is linearly proportional to the applied voltage.
Okay. So is Ohm law is valid also for insulator or dielectric?
Sorry, sir.
Okay. So what is the statement of Ohm's law?
Sir, Ohm's law indicate that the voltage is proportional to the current. When we apply the voltage, then always current is increased with the proportion to the voltage.
Okay. Suppose we increase the temperature, the current will be constant or change?
Sir, can you repeat?
Suppose we increase the temperature, so current will increase or decrease or unchanged?
I'm not sure, sir, but current remain constant if they increase the temperature.
Okay. So it will be increase.
Okay.
Okay. What do you understand by electric potential?
Electrical potential. Sir, electrical potential indicate is that when we if we a unit charge take to infinite to a particular point nearby the another charge, then we can say that how much work is done against to the source charge, source electrical field.
Okay. Can you draw potential for a spherical, solid spherical, infinitely long rod?
Sorry, sir. Yes, sir. Yes, sir. For infinite wrong load,
Sorry, for the cylindrical, infinitely long cylindrical rod.
sir, for infinite cylindrical rod, potential is circular.
Okay. Suppose you have a graphite and you have to explore it. So which electric method you will prefer and why?
Sir, graphite is minerals, and we use sir cell potential. We use the measure the if we use cell potential for the graphite minerals.
Is graphite is conductor, insulator, or dielectric?
Sir, graphite is the sir insulator.
Okay. Do you know Archie's law?
Yes, sir. Sir, RG law indicate that how resistivity depend on the some parameters like porosity and formation factors and resistivity of the water.
Okay. What is porosity?
Sir, porosity is the frictional. We can say that frictional porous volume.
Okay. What is the Gauss law for conductor?
Uh, Sir, for conductor, we can say that the charge always surface on the conductor. So we can say that the electric field on the in the conductor is in the zero in the conductor is zero and uh, outer the and charge on the always surface on the conductor. So we can say that electric field in the conductor is zero and outer side is not electric field zero.
And what is its form for the dielectric?
Sir, for dialectical, we use the in a bound charge and free charge also used in a Gauss law formula.
Okay. Can we polarize water?
Sir, can you repeat?
Can we polarize water?
Sorry, sir.
Okay. What are the telluric currents?
Sir, telluric current is generated by the when due to the ionosphere. You know, sir, when storms ion charged particles come to the suns in the atomic atmosphere. So due to ionosphere, some electromagnetic waves come to the Earth's surface, then and by magnetic component of electromagnetic wave, and it's in the presence of the conducting materials in the subsurface and electromagnetic inductions, there is current produced, which we call the telluric current.
Okay. Last question. Um, what are the eddy currents?
Sir, eddy current, we can say that if we a artificial electromagnetic wave generate in the if we insert in the subsurface, then if we conducting materials presence in the subsurface, so due to electrical magnetic component of the electromagnetic wave and due to electromagnetic inductions, so there is generate a current we call eddy current.
Thank you.
Okay.
So anyone is remaining to ask? Okay, I think we all have done. So for the feedback, please give one by one. Gori, any suggestion?
Yes, your answering was good enough. Almost answered every question I asked. And I think one question about this gradient method. We used to flip the polarity each time we shift the electrode pairs. That method is called leapfrog method, so as to cancel out the error at each intervals we measure. That's a method we use. And about another question, which was that difference. What's the nature of the current we use in IP? It is direct current. Also, it is interrupted, and its frequency also. There is a small frequency also. And in EM, we are using AC. It varies at each time, so that it can make an induction, eddy current within the conductor beneath the subsurface. And it's also different. In resistivity method, we are using direct current with no interruption, I think. That's only from my side.
Okay. Arpita?
पवन आपने सारे आंसर्स ऑलमोस्ट ठीक दिए थे, बस एक वो कंडक्टर, इंसुलेटर और सेमीकंडक्टर वाला बैंड थ्योरी के ऊपर वो आप ये बता सकते हो कि कंडक्टर्स के केस में जो बैंड्स हैं वो ओवरलैप करते हैं, वैलेंस बैंड और कंडक्शन बैंड, बट इंसुलेटर्स में उन दोनों का जो बैंड गैप है वो काफी ज्यादा होता है और सेमीकंडक्टर्स में वो बैंड गैप की जो विड्थ है वो कम होती है। प्लस एक सजेशन है कि आप ना हर क्वेश्चन के बाद यस यस बोल रहे हो शायद से, तो आप उसको थोड़ा सा एक बार देख लो, वो बार बार रिपीट होता हुआ बहुत ज्यादा फॉर्मल नहीं लग रहा
ओके
है ना। और आप थोड़ा सा अपना पेस स्लो करो, थोड़ा सा। योर आंसरिंग इज गुड, बट थोड़ा सा पेस स्लो होगा ना तो ज्यादा बेटर वे में समझ आ पाएगा, कि कई बार वर्ड्स ओवरलैप हो जाते हैं।
यस यस यस
ठीक है, तो आप बस एक ये चीज देख लो, और जैसे ही क्वेश्चन आए उसके ना एकदम से नहीं, क्योंकि आपको चीजें काफी अच्छे से आती हैं, तो आप 1-2 सेकंड का पॉज आप ले सकते हो, ऐसा मुझे लगा है, और आप एक बार देखना। थैंक
थैंक
Okay,
यू
thank you, Arpita. Amrit?
हाँ मैं पवन, तुम तो सब आंसर्स मेरा सही था, बेसिक्स क्वेश्चंस था, और मैं भी यही सजेस्ट करूंगा कि थोड़ा पेस स्लो करो, तो बाकी सब शायद ऑटोमेटिकली सही हो जाएगा। बस, एवरीथिंग वाज गुड।
थैंक यू अमृत।
Okay. Agya?
Yes, it was good. He has depth in knowledge, but only the presentation can be more clearer. That is, I think.
ओके ओके थैंक यू।
Vidut?
यस, मतलब पवन सब आंसर सही दिया, और जो आंसर मतलब गलत बोला, जो मेम्ब्रेन पोलराइजेशन एंड इलेक्ट्रोड पोलराइजेशन है वो तो मैंने बता दिया। जो इलेक्ट्रोड पोलराइजेशन है वहाँ पे ज्यादा वोल्टेज प्रोड्यूस होगा, क्योंकि वहाँ पे इलेक्ट्रोलाइटिक एंड प्रेजेंस है मेम्ब्रेन में, ओनली फॉर इलेक्ट्रोलाइटिक। सो ये थोड़ा गलत था, अदरवाइज ऑल आर ओके। एंड जो अमृत एंड अर्पिता बोला, थोड़ा मतलब थोड़ा स्लो करोगे तो अच्छा होगा, ये है। क्योंकि थोड़ा टाइम लोगोगे, टाइम अगर तुम लोगो से, तो मतलब ज्यादा अच्छा से तुम बता सकते हो, ये है। क्योंकि तुमको आता है, बट तुम इतना स्पीड में बोल रहा हो, इसलिए क्या बोलूं, ओवरलैप हो रहा है, यही है।
अच्छा 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 ओके थैंक यू।
Shanu?
Pawan, its presentation is overall good, and but I expect more from you. But you have good knowledge. I think that you can deliver more, much better. And one thing that I asked, that what is the vertical electronic sounding? which type of discontinuity? You are saying that it's horizontal. You read it somewhere.
वर्टिकल साउंडिंग में मतलब डेप्थ के साथ में अपन इन्वेस्टिगेशन कर रहे हैं, तो तब लेयर हॉरिजॉन्टल होगी तभी तो अपन मेजर कर पाएंगे ना।
Okay, मैं अच्छा discontinuity in direction of the vertical ना।
यदि डिस्कन्टिन्यूटी वर्टिकल होगी तो अपन लेटरल वेरिएशन मेजर कर पाएंगे। यदि लेयर 1 2 3 है डेप्थ के साथ में, तो वहां पे जो डिस्कन्टिन्यूटी होगी तो हॉरिजॉन्टल होगी ना।
Okay, okay.
नहीं, डिसकंटिन्यूटी वर्टिकली होगा, क्योंकि अगर आप ऊपर से नीचे आ रहे हो, वर्टिकली नीचे आ रहे हो, तो आप देख रहे हो कि लेयर 1 है, लेयर 2 है, तो डिसकंटिन्यूटी वर्टिकली हुआ। अगर लेटरल होगा तो वो अलग होगा।
ओके
Okay, overall your performance is good. Okay, I think all giving the feedback now complete.
Okay, Pavan, your all our interview was good, and suggestions have already told to you. So and बस थोड़ा pace slow down करो, and you will be better performer. And a question that I have asked on the very basic on the Ohm's law. So conductivity key variation with the temperature you should know. I think it is very from very basic.
यस आई नो
Okay.
आई नोट।
And overall तो सब अच्छा ही था। ग्रेफाइट इज ए कंडक्टर, अच्छी कंडक्टिविटी होती है उसकी। ऑर्डर जो है अमंग मतलब जितने भी हमारे मिनरल्स हैं, so we can use a suitable method for that as per the conductivity. Okay, एडी करंट जनरेट होंगे, अदरवाइज सब अच्छा है आपका। ओके
आसुदीप,
यस विद्युत।
या ग्राफाइट मेजर करने के लिए तो कौन सा मेथड यूज करेंगे?
अभी तो आई एम ऑल्सो नॉट श्योर, सो
अच्छा,
आई थिंक हाँ, सो द आईपी मेथड आई थिंक इज गुड।
ओके।
सो और आप में से कोई अच्छा आंसर प्लीज दे सकता है तो देन प्लीज।
मतलब तुमने कौन बेसिस से बोला जो मतलब ग्राफाइट आईपी मेथड से मेजर करना अच्छा
Graphite is
होगा?
good conductor now. Graphite is good conductor. That's why its response in electromagnetic wave is good. Means I think method will be. I think EM method, no? Means EM method also its response will be good. It's good conductor.
Anyone? Actually, I have the
But I
question,
think
but
ग्रेफाइट
Can
I
you
ग्रेफाइट
did
repeat
not
the
have the
question?
answer.
Can you
And
repeat the
सेल्फ
question?
my question was the which method you will prefer for the exploration of graphite among the electric method.
फॉर ग्रेफाइट ओरी बॉडीज के तो अपन सेल्फ पोटेंशियल यूज करते हैं ना।
मुझे भी लग रहा था कि ये सेल्फ पोटेंशियल ही होना चाहिए। एक्चुअली ग्राफाइट के प्रेजेंस के ऊपर डिपेंड करके ही सेल्फ पोटेंशियल के हेल्प से सल्फाइड और बॉडीज भी मिलता है, क्योंकि एक ही साथ वो रहने का प्रोबेबिलिटी रहता है।
यस
तो
यस
मुझे भी
यस
सेल्फ पोटेंशियल ही लग रहा था।
और इसमें जो सेल्फ पोटेंशियल की जो एनर्जी मिलती है वो नेगेटिव मिलती है, और उसका जो वोल्टेज होता है वो 100 मिली वोल्ट की मतलब 100 मिली वोल्ट से ज्यादा होता है।
हाँ,
सेल्फ पोटेंशियल ही होना चाहिए।
And why not IP method, Amrit?
कोई स्पेशल रीजन ऐसा नहीं है, मतलब जैसे बोल सकते एक बोल सकते हैं कि मैसिव फॉर्मेशन में रहता है, इसीलिए इसमें में ज्यादा अच्छा डिटेक्ट कर सकते हैं, क्योंकि वो जो मैं बोला कि इसी के मदद से सल्फाइड ओर बॉडीज भी हम लोग ढूंढने का कोशिश करते हैं। और आईपी ज्यादातर केसेस में जो डिसिमिनेटेड ओर मिनरल्स है उस केसेस के लिए एप्लीकेबल है, तो ये बोल सकते हैं एक डिफरेंस।
Okay, thank you. And who wants to give a next interview?
आशुदीप, आपका जो क्वेश्चन था वो वैलिडिटी ऑफ ओहम्स लॉ इन डाइलेक्ट्रिक, उसका क्या आंसर होगा?
Actually, Ohm's law is valid where जहाँ we have the um, a linear relationship between current and voltage difference. So if it is following, then it will valid, otherwise not. Response as based on the response देखते हैं, and for example it is not valid for the semiconductors because current is increases exponentially, but for the initial range it is valid। वो शुरू का कर्व आप देखोगे तो धीरे 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 स्लोली बढ़ता है वो, तो वहाँ लीनियर रिलेशनशिप होती है।
Yeah.
Anyone? Amrit, would you like to give?
Okay, if nobody is ready, then I can try.
Okay, so Gauri, you please start. Pawan, would you
Yes.
like to ask question?
Yes.
Please.
Okay. Amrit, tell me what is the basic application of a resistivity method?
Okay, using resistivity method, we can find the presence of groundwater. We can find the presence of uh, some minerals. These are the basic uses I remember now.
Okay. What is the basic difference between the minerals and rock?
There are many, there can be more than one minerals in a rock. Rocks are formed by minerals, accumulation of minerals.
Do you have any 2 or 3 names of minerals and rock?
Okay, in igneous, basalt is a rock, granite is a rock. In sedimentary, sandstone is a rock, limestone is a rock. And in, if we consider a mineral, then pyrite, pyrrhotite, limonite, all these belongs to minerals.
Any example of the metamorphic rocks, which is made by sedimentary rocks?
Okay, marble is famous example of metamorphic rock, which comes from limestone. Then quartzite is another one, which is metamorphic form of sandstone.
And by shell, shell is a sedimentary rocks.
Shell becomes slate.
Oh, so, which rock have more resistivity? If we compare the three of the sedimentary, igneous, and metamorphic, so which rock have more resistivity?
More resistivity. Normally, basic igneous rocks show more resistivity values among all these three.
If we compare to the sedimentary and igneous,
Then also igneous rock has higher resistivity.
if we compare two rocks, one is the sedimentary and another is the metamorphic, and which have more resistivity?
Then metamorphic rock will have higher resistivity.
Why?
Normally, resistivity value actually depends on the presence of water porosity. So when a rock is undergoing metamorphism, then due to presence of higher pressure and temperature, compaction occurs within the grains. So porosity decreases as well as the groundwater. So resistivity increases.
You mentioned that porosity. What is the porosity?
Porosity is a ratio of void space present in any rock.
What is the importance? Why we are calculate for porosity?
Porosity is important because within pores there may be liquid, which is water, which is hydrocarbon, that may play any significant economic role. So porosity is important to know.
Do you know any relation between the porosity and uptake resistivity? And what is the code of law?
Using Archie's law, we can formulate a relation among these two.
Okay. And what is the if we compare to the resistivity in other method, what is the advantage of the resistivity method?
Comparing with other methods,
Like a,
resistivity, uh, like,
like a gravity, magnetic.
okay, using a resistivity method, we can have two type of information. One is lateral variation of any discontinuity and how the parameter varies with depth. So it is on our hand. It depends on the type of source or type of arrangements we are using. So we can control it. This is the main advantage of electrical over other two.
Okay. What is the basic application of cell potential?
Basic application is to find the sulfide, massive sulfides.
Okay. Another one is
Sorry, I could not get.
okay.
Please repeat the question. I did not probably could not get the question.
Okay, forget this question. I will ask new question. In a cell potential, we obtain zeta potential and nearest potential. What is the basic difference?
Zeta potential is basically depends on the type of origin. Depending on the origin type of the potential, we classify among these two, between these two. Zeta potential is mechanical in origin, where due to pressure difference and flow through any capillary tube, this potential arises. Where zeta potential, where nonce potential arises due to difference in concentration of fluid present within the subsurface, as well as the contact. So Nernst potential, consider diffusion potential and concentration potential. I have forgotten the name. The difference is mainly on origin.
Okay, okay. And do you know about the mineral potential?
Due to presence of minerals, which potential comes is termed as
For mineral, the value of mineral potential is negative or positive?
in most cases we have negative potential value.
And some cases we obtain the positive value. Is right?
In few cases we also have positive values.
In field survey, we use two methods for measuring cell potential. Do you know?
To measure cell potential, we have two type of methods. One is fixed base method, where one electrode is fixed at the base and another we traverse in different location, and another is constant gradient method, where a constant separation within the electrode is maintained.
Okay, okay. What is the range of the resistivity for oil?
It should be higher, but I am not remembering the correct figure. It should be probably mega ohm meter range. I'm not sure.
Omega. Okay. So if you compare to the water, which have more resistivity in oil and water?
Oil has more resistivity.
Okay. Thank you, Amrit.
Okay, thank you.
Vidut,
Yes. So, Amrit, what is the importance of K factor in vertical electrical sounding?
Is it geometrical factor? K factor, what I remember is probably geometrical factor. So it tells us about the how geometry is important. Geometry of electrodes are important in apparent resistivity measurement.
No, no, no. Basically, I'm just saying in vertical electrical sounding, that means you have horizontal layer, right? Row 1, row 2, row 3. So how you get to know that this layer is conducting or insulator in that perspective?
Okay. So for three layer case, we have four type of master curves. Having the variation of watching the variation of resistivity with depth, if we find any K type graph, then it it means that the resistivity of intermediate layer will be higher comparing with the top and bottom layer. So this is the significance of K type curve.
And for two type layer, let's say your K factor is -1. So what is mean that? If you have two layer, first layer have resistivity row 1 and second layer have row 2.
And we are having the reflection coefficient -1.
Yes.
This means that uh, row, row 2 one will have infinite value, so I'm getting confused.
Okay,
Probably
okay. Yeah, row 2 equals to 0. That means uh, the second layer is insulator.
the
And
formula is row 2 minus row 1 divided by row 2 plus row 1. So
Yes.
okay, rho 2 should be 0.
Yeah. And so which whenever you have derived this rho 1, rho 2 based on this k factor, so which basics law applied here?
In electrical resistivity method, we always, in most of the cases, apply Ohm's law.
Okay. Then what are the boundary condition? What are the important boundary condition that should satisfy to determine this law, this k factor?
Okay, due to inhomogeneity, the potential value, actually the electric field value, transverse component of electric field and normal component of current density, this should be continuous at the boundary.
Yes, yes. Okay, Asudev, I have done. And the basics law, ये law हो गया law of refraction. मतलब law of refraction से हम लोग निकालते हैं tan theta 1 by theta 2 equals to rho 2 by rho 1, then k factor comes from that.
अच्छा, ठीक,
Okay.
thank you.
Thank you.
Okay,
Gauri?
Asudev.
Yes, yes. So tell me what's Ohm's law? Hello?
Yeah, Ohm's law states that current flowing through any conductor or between 2 points is proportional to the voltage applied in between that 2 points, keeping all other parameters constant.
What are the different electrical conduction methods?
Electrical conduction methods, different
Yeah.
electrical conduction method.
Yeah.
We,
Explain.
we can classify into 3 types. I remember electrolytic, electronic, and ionic polarization. I
Ionic
don't
and
think
electrolytic are same, right? It's dielectric.
electrolytic and electrode. Okay.
Okay. Which one of these three is dominant or most uh, uh, dominant in case of measurement?
In most cases, electrode type is more dominant.
Okay, okay. Mm, mm, what are the different type of electrode configuration you are using in resistivity method or any electrical methods?
Depending on the presence of depending on the distance between the electrodes, we classify in many types. So some are Wiener configuration, Schlumberger configuration, dipole configuration.
Okay, which configuration is mostly used in lateral profile?
Wiener configuration is mainly used.
So what about vertical electrical sounding?
For that, Schlumberger configuration is more useful.
In IP method?
For IP, dipole is preferable.
Okay. And what is telluric current and how does it occur?
Telluric current is a natural earth current, flows parallel to the earth layer beneath the earth's surface, and it is generated due to the ionospheric currents.
Okay. Then what are the parameters we are measuring in an IP survey?
If we can classify into two domains, in time domain, we are measuring chargeability, metal factor, and in frequency domain, we are measuring frequency effect, percentile of percentage frequency effect.
Okay, then what is this frequency effect?
Frequency effect basically measures how apparent resistivity value changes in two different frequency values, or we can
Okay.
say how the conductivity actually changes in two different frequency.
Okay, what is the general um, variation of resistivity with frequency?
Okay, uh, as it is used in IP, so if frequency increases, resistivity should decrease.
Okay, and then what is the physical meaning of this chargeability?
Chargeability is actually actually measures how in materials withstand the voltage, or if we consider the graph of decay, then the area within the voltage graph and time graph gives us chargeability.
Okay, then how is the presence of conductor influence this chargeability? Disseminated conductor.
For conductor, it increases. Chargeability is measured in milliseconds, so for in presence of conductor, it values actually larger comparative other cases.
Okay, what is apparent resistivity?
Apparent resistivity is the resistivity which is not the true one and arises due to inhomogeneity in the subsurface.
Okay, what are the four shapes of apparent resistivity curves in a three-layered medium?
And K, H, Q, and A.
Can you explain it a little bit? What's the nature of resistivity variation within this layers in each case?
Okay, in K type, it is actually bell shaped, so how the resistivity value changes with depth. These four graphs suggest that for Q and H, the intermediate layer has maximum and minimum resistivity values respectively, and for Q values, the resistivity keeps on decreasing with depth, and for A, it keeps on increasing with depth.
Okay, that's all from my side. Thank you.
Okay, thank you.
Thank you. Arpita?
Can you tell me the key electrical method?
I did not get your question.
Can you tell me the three types of electrical methods?
Okay. It can be classified as resistivity method, cell potential method, and induced polarization method.
What is the basic difference between all these three?
In resistivity and IP methods, these are classified as active method. We use source, and in cell potential, it is natural method. Within cell resistivity and IP also, the type type of sources or the method we apply are different. Uh, we use continuous current source in resistivity, but here we turn the current off and see the capacitive effect.
Okay. What is apparent resistivity?
Apparent resistivity is actually it is not the true value, the resistivity value which arises due to inhomogeneity, and also that's what.
Okay. Is there any way possible that we can convert the apparent resistivity to the true resistivity?
Yes, it is possible if the layer is homogeneous, or we can somehow obtain homogeneity.
Okay. What is the difference between sounding and profiling?
Profiling is measuring any parameter in horizontal direction, and sounding we are obtaining the information with depth.
Can you explain the role of capacitors for AC current and DC current?
Capacitor is a DC blocker. It permits only AC to pass through it.
How is it possible? Can you explain it?
It can be explained with the reactance a capacitance actually applies to the current flow. It is inversely related with the frequency. So normally in DC component the frequency is 0. So it plays infinite resistance to the flow. So no DC will be permitted. Whereas in AC the reactance is comparatively lesser. So AC current can pass through it.
Okay. What is capacitance?
Capacitance is a phenomena which can accumulate electrical energy, or which can store actually.
Okay. Can you arrange the arrays in the order of depth of penetration, increasing order?
Sorry, order of penetration.
Yeah. Can you arrange the different type of arrays we use in resistivity method in increasing order of their depth of penetration?
Okay, so increasing means it will increase. So slumber. First one will be um, Wiener configuration, then Schlumberger, then dipole dipole, then pole dipole, then pole pole.
Okay, that's all from my side.
Thank you.
Thank you, Arpita. Shanu?
Hello.
Ah,
Hello. Okay. How the electrode separation depends on the means current current penetration. This electrode separation is depend on the current penetration. Depth of current penetration.
okay, there is a relationship using which we can relate these two terms, how the percentage of current flowing beneath a depth, there is a mathematical relation.
Okay, means what is relation? If you remember it.
Uh, Current I if it is flowing in x direction and I0 is the current which is at the ground, then the ratio is probably 2 by pi tan inverse 2z by L, where L is the electrode separation and Z is the depth.
Okay. Okay. Okay, which type of instrument we are using for the resistivity survey?
In resistivity survey, we are interested to know the potential difference, so we shall use voltmeter.
Okay. And what principle is voltmeter based on?
I think everything depends is dependent on Ohm's law.
Okay. Do you know the coefficient of anisotropy?
Coefficient of anisotropy is how the resistivity actually changes with vertical and horizontal direction. So the ratio of these two gives us the value of coefficient of anisotropy mathematically.
Okay. Means why there is means a difference in the in vertical direction and horizontal direction.
Uh, Please repeat it.
Means you said now the coefficient of anisotropy, it is the ratio of the vertical and the horizontal. No.
Uh-huh.
So means why there is difference in the vertical and horizontal.
Okay, in some cases, if we consider the layering of layering of different different earth layers, so in some cases it has same property in in the same layer. Within different layers, the property changes. That may be the reason that why in different direction resistivity changes.
Okay. Anything of anisotropy? Why you are measuring it?
Why we are measuring anisotropy?
Yes.
Uh, I don't have any solid reason to say.
Okay. So between limestone and sandstone, which one is the more resistive?
Limestone is probably more resistive.
Limestone is more resistive. Why?
It can be explained using the concept of porosity. I'm not sure, but resistivity phenomena depends mainly on the presence of porosity, presence of pores.
Okay. Between if I given that the four layer, means one is dry soil, one is mud soil, and sandstone, and salt water. Can you arrange it? Which one is the in resistivity water?
Sorry, I please repeat it. I have to write it down.
Okay, dry soil, mud soil.
Dry soil, mud soil. Then
Okay, sandstone and salt water.
sandstone, salt water,
Yes,
which have higher resistivity.
yes. You could tell me in increasing or decreasing order, whatever you are prefer.
Okay, I am I'm telling in increasing order.
Okay.
So I think first dry soil will come, then sandstone, then mud soil, then salt water.
Okay. Okay. Do you know about the principle of equivalence and principle of separation?
Principle of equivalence and principle of separation.
Yes.
Okay, in some cases, principle of equivalence means we are considering mm, more than one layer case as single layer event. So this is principle of equivalence, and principle of separation. Uh, also, I am not sure, probably completely, but it actually neglects the presence of some layers. That may be the nomenclature what suggests. I'm not sure.
Okay. Okay, I'm done. Anyone can ask question.
Thank you.
Thank you.
Aragya?
Okay. So, what is the basic principle of resistivity method?
In resistivity method, current is propagated to the subsurface and potential difference we try to measure. From these two values, resistivity of within the subsurface layer is measured.
Okay. What type of current we use, DC or AC?
Low frequency AC is used
Why not DC?
because the conductor or electrode used for propagating currents, they show some the charge accumulation if DC is used. So spurious spurious readings are obtained.
Okay. Okay. The resistivity we measure, is it true or apparent?
No, this is apparent.
How do we get the true one?
True means if we consider some special case that only homogeneous layer is present beneath the survey area. So for in that case, we can consider that apparent one is giving the true value of that layer. Some highly resistive uh, rock layers beneath the subsurface, if we consider two layer cases, then
Okay. Even if the soil is inhomogeneous, can we get the true resistivity by computer iteration or modeling? Can we do this?
as I know, as much as I know that if we consider two layer within the subsurface, and in some cases rho 2 can be assumed infinite, that all the current lines are passing to the upper layer and maintaining the proper distance within the electrodes, it we can assume that we are having the rho 1 value, but it is not actually the scenario.
Uh, okay. Okay. What are the limitations of electrical method?
To obtain the field values, we have to go through go to that location, physically insert the electrodes in the surface, and this may not be possible in all scenarios, in all uh, land places. So this is the main advantage, main disadvantage. And also the propagation depth of penetration using this control source is not of great depth, or can't give us deeper information. These two are main disadvantages.
Can you tell the relation between the frequency of current and the depth it penetrates?
Normally, it is inversely related with frequency, depth of penetration, 1 by root over f.
Oh, okay, I'm done. It was good.
Uh, what are the natural potentials?
Okay. Mm, Depending on the origin, it can be classified into mechanical potential, electrochemical potential.
What is that? Mechanical and another one.
Mechanical potential actually is related with capillary tubes where pressure difference is maintained, and through that uh, any electrolytes or any flowing through that. So for that case, mechanical potential comes, and electrochemical, here the chemical reactions also play a significant role due to difference in concentrations, due to contact between electrode and the subsurface materials. These comes. Mineralized potential also comes under electrochemical event.
Okay. So, what is the limitation of SP method?
SP method does not give us the good. The first limitation is very smaller depth of penetration. It only gives us information up to 50 meter. Then also, uh, it is not it can't be said that it is accurately delineating any mineral zone. It may be graphite bodies also. So this non-uniqueness problem.
Okay, okay. So come to the resistivity method. So how the resistivity offer the resistance offer this in this material is different from the seismic method. We also have the impedance. So what is the difference between these two?
Okay, for clarification, I am again telling this the question, repeating the question. You are asking about difference between resistivity and seismic method.
No, 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 no. I am asking about the in the resistivity method we have a resistance basically material providing resistance. So how this resistance is different from the impedance that is in the seismology in the seismic method.
Okay, in seismic, we are dealing with the change in impedance, which actually involves with two parameter. One is velocity of any wave flowing that medium, and the resistivity value at any layer. But here in resistivity measurement or method, we are dealing with only resistivity or resistance, we can say.
Are you sure? These we are dealing with resistivity in seismic method.
Okay, I think I have just I have been confused with this rho symbol. Probably that is density, and here it is resistivity.
Okay, good, good. So, okay. And what are the active and passive methods? What do you understand by the active and passive methods?
Active methods are basically those methods which need external sources, and passive methods depends on natural source, does not need any external sources.
Okay. So, we have the natural, means the natural sources like active methods, passive methods, sorry. So, why do we need active methods?
Actually, we are interested to mm, to have the information of the subsurface in proper resolution. In passive methods, we can't resolve the subsurface quite well, and this is not also on the observer's hand to have control over the resolution. So active method is better for that perspective.
So, is the active method and the direct method are same or different?
Sorry, active method and
Direct method, are they same or different?
I actually could not get your question. You are asking about direct method means which direct method?
Yeah, direct. We can also classify geophysical methods as direct method and indirect method. So, are the direct are the active method and the direct method same or not?
Okay, sorry, I don't have information about it. I don't know it.
Okay, okay, no issue. What is electric potential?
Electric potential, within a particular location, up to which location of a electrical charge, it can affect the nearby charges. It can be explained using potential.
So, what is its formula for a point charge?
For a point charge.
Yes.
Okay. Sorry, I am not remembering it. This is 2 by 5. Some formula is there, I have forgotten.
Okay. What is Coulomb's law?
Coulomb's law. Hello?
Yes, yes, Coulomb's law.
Okay. Coulomb's law is basically the tells about force acting between two charged particles if they are placed within a distance, how the force act within these two. This is a proportional to q1 q2 by r square.
Okay. So, so is electric field is conservative field or not?
Yes, electric field is conservative in nature.
It will always be conservative, or depends on the situation.
Electric field is conservative in nature.
Okay. So, what is the condition for a field to be conservative?
Work done under that field should be path independent. It should be point function, and also it can be obtained from any constant gradient of potential. It can be obtained from.
Can you relate it with any uh, Maxwell equation?
Maxwell's del dot del cross E, third formula.
And what is the third equation?
So minus del V by del T.
Okay. So for a positive point charge, what will be the direction of the field lines?
It should be
Is is anyone also facing the voice issue, or only I am?
Yes, Ansudeep, I also face the same issue.
Okay. So Amrit, will you please repeat your answer?
okay. I answered that it should be radially outward direction. Right? You asked about.
Okay. So the okay, on which factor resistivity depend?
Please repeat it.
On which factors the resistivity depend?
Okay, resistivity actually dependent on uh, material type, presence of porosity.
Does it depend on temperature?
Uh, res- Resistivity is dependent on temperature also.
How?
It actually increases with temperature.
Okay, you will increase the temperature, so resistivity will also increase.
There is a relationship I remember with temperature, same as linear expansion.
Okay, okay. So do you know the vector form of Ohm's law?
Please repeat, Ashudeep. I actually have network issue now. I've come aside.
Yes. Do you know the vector form of Ohm's law?
Okay. J equal to sigma E.
And what is J here?
J is current density.
Okay, and what is the direction of J for a wire, cylindrical wire?
It should be same as E. So if it is propagating, depends on the propagation of current direction. I think it should be radially outward.
Okay, what is tomography?
Tomography is knowing about the cross section, knowing information about cross section. Study about cross section. This should be the better term.
Okay, so my last question: How will you how will you contribute to the GSI if selected?
Actually, I have to think about it. How will I contribute? If I get opportunity, I will definitely find some reasons to contribute.
And what are those reasons?
Uh, I have not anything. I have not thought anything like that till now, but I will think about it.
Okay, thank you.
Okay, thank you.
So, uh, please, everyone give feedback one by one. Gauri,
You almost answered every questions I asked correctly. Apart from that, there is a confusion between those types of resistivity curves. You just look into it. Beyond that, everything was right, and you can somewhat improve your confidence level. I think that's all.
thank you. Pawan,
Sorry, Gauri, I could not get your last point. What did you say about confidence level?
You can improve it somewhat, or at least, mm, yeah, answer it with some more confidence.
Okay, thank you.
हाँ, यस यस। सो अमृत, मैंने जो से आपसे क्वेश्चन पूछा 3-4 वो आपने सही बताया। एक क्वेश्चन था कि ग्राउंड वाटर का जो रेजिस्टिविटी वेरिएशन कितना होता है, वो आई थिंक 0.5 से 300 ओमीटर होता है उसका वेरिएशन। ओ हाँ, सेम गौरी ने जो बोला है वो ठीक बोला है। समटाइम्स मे बी
उसका
लोअर कॉन्फिडेंस है ना, सम इफ यू गिव द आंसरिंग, तो मुझे ऐसा लगता है कि सही है गलत है, तो वो चीजें थोड़ा सा इंप्रूवमेंट, अदरवाइज ऑल ओवर गुड।
पवन
अच्छा,
पवन
ठीक, थैंक यू।
यस यस।
Vidut,
या कितने बोला रेजिस्टिविटी ग्राउंड वाटर में?
0.5 to 300 रेंज होता है इसका, काफी ज्यादा रेंज होता है।
अच्छा अच्छा, ओके ओके।
Vidut,
यस, सो या मतलब ये ओवरऑल गुड ही है, गुड है। कोई मेरा जितना भी क्वेश्चन पूछा वो सही आंसर दिया। और पवन और गौरी जो बोला कॉन्फिडेंस लेवल, मतलब तुम थोड़ा धीरे धीरे बता रहे हो, इसलिए मतलब ये या हो रहा है, जो ये कॉन्फिडेंस का थोड़ा बहुत कम है, बट ये एक्चुअली मतलब क्या बोलो एडवांटेज भी है। थोड़ा धीरे धीरे बता रहा हो, इसलिए तुमको जितना भी पता है वो तुम टोटली डिलीवर हो रहा है, इसलिए ये भी अच्छा पॉइंट है। बट ठीक है, मेरे हिसाब से कोई प्रॉब्लम नहीं है।
अच्छा, ठीक है,
thank you. Shanu,
थैंक यू।
Shanu has gone. Alpita,
इट वाज गुड। आपकी कम्युनिकेशन भी बहुत अच्छी है और आपका पेस भी बहुत अच्छा है कि आप जो चीजें बोल पा रहे हो वो बहुत अच्छे से समझ आ रही है।
ओके, थैंक यू।
Cambridge, overall interaction with you was good, nice. So, why I will repeat कि जो आप deliver करना चाह रहे हो, it is reaching to us. So and improvement के लिए हाँ थोड़ा confidence, just little but 5% बढ़ा लो बस, ज़्यादा कि सब तो अच्छा ही है देखो. And overall interview was good. Thank you.
Okay, thank you.
Pawan, you can stop the recording.
Orpita?